So, about a month ago, Joanne asked a question on my single nucleotide polymorphisms video about how these SNPs affect phenotypes, how they affect genotypes, and how they affect homozygosity. Now, that is a very, very basic, but yet extremely complicated question, which is why I couldn't just rip you off an answer, because really, there's no answer to that question. You have to build up these 5 terms and understand them and how they work with each other, and then your question will morph into something else most likely. So let's go ahead and start off by looking up what phenotype is, how people understand it, how it's defined, and then how it works with genotypes and the 3 different types of genotypes there are out there. So a conceptual approach. Okay, so first, when you first asked me the question, my answer to what a phenotype is a phenotype is a expression of a gene. And what the gene expresses is based on its genotype. And there are 3 different types of genotypes: homozygous, heterozygous, and homozygous recessive. Sometimes the first one I listed is listed as a dominant, but really I think that we shouldn't be saying homozygous recessive. We should just say recessive and understand that it's homozygous recessive, but that's a different battle for another time. And so I didn't want to, get it wrong when you first asked me, so I started looking in my textbooks for phenotype. And to be honest, I really hadn't looked into the basic definitions in a long time, and how you're supposed to have a good foundation if you have no base. Okay, so phenotype. Appearance or manifestation of a characteristic. Okay, that means not a lot. Oh, this is embarrassing. Oh, there it is right here. An organism's physical characteristics. Okay, that's my favorite book, so. Okay, so this one's interesting. It says that it's an observable characteristic of an organism, motility, morphology, and then it says to reference genotype. And when you go to the genotype, it says a complete genetic makeup of an organism. Reference phenotype. Okay, so this one says, see page 7 for the definition. Page 7, let's see. Oof. Did I have some notes? I don't like losing my notes, just in case. I know it looks messy, but whatever. He got the job. Here he goes. Oh. Refer to appearance or physical structure of an individual as its phenotype, and to its genetic composition as its genotype. And we'll just do the last one for good measure. Oh, this is a glossary index. I shouldn't have said anything. Okay, so basically, this book gives a nice little section entirely to genetics of 2 pages, and so the external experience, the external appearance phenotype of an organism is determined in large extent by its genes it inherits, genotype. Okay, so that's the textbooks, and really I just want to show you that the textbooks don't always have the best answers for these genetics topics, especially when you're trying to really dive deep into genetics. You need to basically rebuild your base, and I always say that I do human molecular genetics and I don't do any other type because it's different. Things change. The definitions can mean different things. So if you look at the National Human Genome Research Institute website, that's where I would want to go for my information because I'm into human molecular genetics. If you're into other types of genetics, you can go to other sources. So as far as phenotype goes, let's see what they list as the definition for phenotype, which is a phenotype is an individual's observable traits such as height, eye color, and blood type. The genetic contribution to the phenotype is called the genotype. So basically, they took kind of what all the books were saying and combined it together and broadened the term. Okay, so the thing is, really, I don't think that any of these textbooks are wrong. I think that the National Human Genome Research Institute is right. I think that all their videos online are absolutely phenomenal and you'll get a great understanding of genetics, but you really need to understand the basics. So let's go ahead and really dive deep into what a phenotype is, what a genotype is, heterozygous and homozygous recessive. And the only way that we can really dive deep is to have a target, pick a gene, and then study it and figure out what chromosome it's on, what's its alleles, how are we telling its genotype. And I'm going to use alkaptonuria, and I did another video on alkaptonuria already, and I use alkaptonuria because everyone uses alkaptonuria to teach because it's very understood. It's the gold standard for teaching. Okay, so first, I was always taught top-down phenotypes to genotypes. So if you were looking at it from top-down, from genotypes to phenotypes, you would basically have your DNA to mRNA to enzyme and then to substrate metabolites, and then parallel to that, you could look at it as the genome to the transcriptome to the proteome to substrates and metabolites. So that's like physically what's going on, and that's like the biology genetics. That's the definitions that you find in the books. Those are for like the physically understanding what's going on. To understand what's going on in the genetic files, you really have to have an understanding of the more hardcore stuff. So like understanding a gene. So we have a gene. Better yet, let's start with a phenotype. And let's say I have dark urine and everyone else has yellow urine, or most other people have yellow urine. And I go and I do some digging in my family tree and I find out that both my grandparents had yellow urine, and I just wanted to figure some things out. So the first thing I'm going to do is I'm going to start listing some knowns. And the first known I have here is that dark urine is the phenotype for AKU. Normal urine is the wild type, just what everyone else has there. It's the HGD gene. So there's nothing, not that there's nothing special about it, but it's just what everyone else has. It's the allele most found in the wild. And okay, so now let's start working on genotypes and building my fake family tree. So let's say both my grandmothers had alkaptonuria or dark urine, and no one else in the family did, and both grandparents had 5 kids. So that's 10 brothers and sisters, and none of them had black urine. And then my mother and father from these 2 different families got together and had me, and now I have black urine, but neither of them do. So let's just start with this scenario and just do genotypes from my grandparents down to me. And hopefully this will give you an understanding of the homo, hetero, and recessive genotypes. And we'll start at the top with the 2 GMOs. So we have GM1 and GM2. Both of them are homozygous recessive for AKU. So that one's easy because they both have the little b's in each spot. They can only give the little b's. And so then we have grandpa. Now, grandpa's a toss-up. You see, we know that all their kids have yellow P, which means that both grandfathers have to have at least one allele that is a normal wild type HGD allele. And they could have both of them. Now, it would make more sense for both grandpas to be homozygous dominant, but it's not 100% sure. They could be heterozygous. You see, each parent donates one allele at each gene location. So you can't assume that both these granddaddies are homozygous for the dominant allele. So big grandpa, we know one of them, but we can't be 100% on the second one because you can flip a coin heads 5 times in a row. And so then we have all the children. All the children are going to be heterozygous. And you know they're going to be heterozygous because they all have yellow P, which means they have at least one normal wild type allele. And then the grandmothers have black P, which means they can only donate one of those AKU alleles. And so that means that all the kids are going to be big B, little b. And then there's me. So when my 2 parents met, they were both big B, little b. And I basically got an allele from my father, which was a little b. And then I got an allele from my mother, which was a little b. And that means that I flipped a coin twice and got real lucky with black piss. Okay, so now that we've got a better understanding of phenotypes and genotypes and we've done a little tree, now we can go back to those old Putin squares and we can understand Joanne's question about single nucleotide polymorphisms. Now, SNPs are just the most common variation of these mutant alleles, right? So when you see little b, that's because that allele has a SNP in it, right? Because it wouldn't be a little b if it didn't have a single nucleotide polymorphism in it, or it could have another genetic variant that's less common, but that's the little b in those Putin squares. So the big B is the wild type, and I feel like that kind of answers your question a little bit better. And really, I'd just like to leave you with that genetics is just a difference of alleles. And when you see genes, just gene really means nothing. because it needs a location. So it needs a locus. And at that locus, everyone's going to have two different alleles. So Dr. Chai at the University of Central Florida always preaches that genetics is the study of, or genetics is the difference of alleles. So have a good one, Joanne. Oh, one more thing. In my video, I say mutant a few times, and I really don't mean that. I mean variant. An allele that's not a normal type allele shouldn't be considered a mutant allele, and that word has like a negative tone in the industry. So I'm pretty sure that the NIH, I've seen in all their videos, they're calling it variations or variant. They're getting away from the mutant alleles. So I just wanted to make that correction because I really need to stop calling them mutant alleles too.